Hello, my name is Tarek, and in today's lecture, we will see the applications of stack, the areas where we can use stack data structure in order to solve a problem. Uh, you must have seen such expressions in your school life. There are two operands and one operator, and you must have evaluated such equations in your school days. Uh, if I want to evaluate, let's suppose this expression, then how would I evaluate this? Here, I need to take care of the precedence of operators. Let's say I have multiplication operator and I have addition operator. So what would I do first? Should I add these two values, or should I do the multiplication first? As the rule says, I know that multiplication and division has higher precedence than addition and subtraction. So what I'll do is I'll first multiply these two values and then I'll add. So the result will be 4 to the 8 plus 2, that equals to 10, right? If I want you to write a program and for these expressions so that I could easily get the answer using that program, so what would you do then? You will definitely try to write a program that will evaluate these expressions. But these expressions are not very much friendly for the computers, for the machines, because we have brackets, we have operator precedence. These are the the things we need to take care. So the computer scientists have come up with, they thought on this problem, and they came up with a simplified format of this expression. This expression is in infix form. We call these forms as an infix form. Infix form of expression, right? So now if I want to evaluate this, so what I would do first? I would first evaluate the innermost bracket and then the outer bracket, right? Because it's easily is readable to me, and I can read that and I can evaluate this. But for the computers, it's a bit of complex process. I need to take care of the brackets and the order precedence. So in order to remove this complication, the computer scientists came up with a solution, and they call it postfix or infix or prefix problem, prefix expressions, right? So what we do is we convert our infix expressions into postfix or prefix form, and that form is a simplified form in which there is no bracket, there is no need to take it the precedence of operators. We just have a simplified format of these expressions that can be easily evaluated. So the effort that we made is the result of the effort is to simplify the expression, to remove the complexity of the expression. So how we can convert our infix expression into an postfix or prefix expression? There are two ways of writing expression, that is prefix and postfix. In prefix, we append we place the operator on the left hand side, and in postfix expression what we do, we take the operator to the right hand side. So these are two operands and this is an operator, right? So the pre and post refer to the position of the operator with respect to the two operands. Now consider the infix expression, which is a plus b multiplied by c. As we know that the multiplication is done before addition, so if we write it in this format, like a plus b bracket is bracket start b multiply c bracket close. This is same as writing this one, but this is more expressive. This is more readable and easy to uh, understand, right? So now let's try to convert an infix expression into a postfix form. We have a plus bracket start b multiply c bracket close. So first we will do is we will evaluate the brackets because brackets has the highest precedence. So what we did, we converted b multiply c into b bc, and then we take the operator out and we placed it at the right hand side, right? Because we are trying to convert it into prefix form, postfix form. And the next step is what we did, we uh, placed the plus sign at the last, and now this expression is more simplified, and this is the last form. As here you can see there is no bracket, and the expression is simplified now and has been converted into postfix form. So why we use notations, why we are converting these into some other expressions? Because infix notation is easy to read for humans, whereas postfix and prefix notations is easier to parse for a machine. The biggest advantage is in prefix and postfix notation is that there is never arise an equation like order precedence and brackets also. So let's take an example here. We have 12 plus 3 multiplied by 6 plus 23 plus and divide. So how would we evaluate this? In order to evaluate an postfix expression, we start from the left hand side and we then move towards the right hand side. So starting from the left hand side, 1 2 plus, first we will evaluate this. This means 1 plus 2, right? So let me write it here. 1 plus 2 is equals to 3. So the result of this expression, because we always start evaluating expression from the left hand side. 1 2 plus, it means 1 plus 2, that is 3. Now the result of these three characters will be then multiplied by this one. So what will it become? Multiplied by 3, because we have multiplication sign and we have 3 also. So the result is now 9, right? Okay, now we have evaluated this part of the expression. Now we have 6 and plus, so we will add 6 into this and we will get 15, right? Now we have evaluated this much part. Okay, now we have plus, so we will write here plus, and we have 2 3 and plus. So what we will do is we will add 2 and 3. So we will add 2 plus 3, and what we will get? 5. So we have 5. Sorry, this plus will not come here because this plus is associated with this one. So here we will divide this with 5, and the answer will be 3. As you can see how easily I have evaluated the expression using the postfix form, and this is the postfix form and we have got the answer. Now let's see its infix form. Here is the equivalent expression that we evaluated, the equivalent of the postfix expression in the form of infix form. As you can see, how many brackets are we using it to easily express or to write this expression. So the postfix form was more simplified and there was no brackets we used. There were no brackets used. But in the infix form, we need to use some brackets in order to make this expression readable and to correctly express the expression. So precedence of operators, we will use binary operators, that are addition operator, subtraction, multiplication and division operator, and exponentiation operator. So in the precedence of order, the precedence of operators will be, parenthesis will be the highest order. Then we have exponential, which is of power, like 2 power 3 will be equal to 2 multiplied by 2 multiplied by 2. That's equal to 2 to the 4, 4 to the 8, right? We have multiplication and division operator, and in the last we will do the addition and subtraction. So here is the example. So here we will use to evaluate our postfix expressions using stack. We will use the stack to evaluate this expression. And how we will use this? We will use this stack. I'll explain in the later videos. So right now, the purpose of this lecture is to show you how we can convert our infix expression into the postfix expressions, and why are we doing it. And as far as evaluation is concerned, using this stack data structure, we will see in our little videos. So thank you for watching.